Hello, I'm Vinay Gupta, founder of the Hexier project, and I want to talk to you about distributed manufacturing, climate change, resource scarcity, and how all these pieces fit together into a different model for how we might approach the upcoming chaos that we're going to see in our societies caused by climate change. So I guess I should start with a very brief bio. I am nearly 50. So I first heard about climate change as an issue in the mid 1990s from a guy called Albert Bates of an organization called World Watch. And he sat me down and explained to me, Vinay, there's this thing called the environment, and by the time you're grown up, we're going to have run out of it. We're just going to have mashed this. And I walked away from that really quite shocked. It was like, I'd never really heard of that. I was in the kind of enthusiasm that came from the end of the nuclear era. We no longer expected nuclear war to be our future. It was suddenly like, hey, there's real cause for optimism here. And then suddenly it was like, no, you don't understand. There is something bad coming. And then what came out of that was a sort of 5-6 year period where I didn't really have a plan. I didn't know what to do. Didn't seem like my problem. And then life rolled around in 2002. I was asked to take a crack at designing a refugee shelter that could be transported with the refugees so that if they were allowed to come back to their homes, but their homes had been destroyed by, for example, flooding, they would be able to take the shelter with them and then deploy the shelter to protect them, and that would be kind of the next step in disaster shelter evolution. And I had a very strong interest in Buckminster Fuller's work. I'd done a lot of work on that. And so I invented an incredibly cheap, small geodesic dome structure called a Hexier. And the Hexier is very quietly one of the world's more successful open hardware projects. They took root at Burning Man very, very, very strongly. And there are now maybe half a dozen companies commercially producing them for Burning Man. There's a second generation shelter called the Shift Pod, which is in industrial mass production and is being used in refugee camps. And at Burning Man, probably something like 10 to 20,000 people stay in the Hexier every year. There are hundreds of videos online about how to produce them, how to manufacture them. And in every way, shape and form, this is an open hardware project which has completely slipped into the vernacular. I always said that I wanted the Hexier to have the same intellectual property status as tying a shoelace. I wanted it to just be a thing that you did, like mortise joint or make a bookcase, make a Hexier. I want no copyright, no trademark, no patent. And that approach has been very successful. And the thing about it is it's not a cool project. This was a critical decision we made. There were kind of two ways that we could have taken it. We could have gone very sort of high concept, high art. This is an amazing thing. It will change the entire world. You should all pay attention to this thing. Oh my God, this is the coolest thing you've ever seen. Wow, 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 wow. And we very deliberately didn't do that. We chose to spread it as a very, very dull kind of, matte, kind of olive drab, like this is just a thing you could do. It's really useful sometimes. There is the potential we're going to see 150 million, 250 million, 350 million climate refugees. This is the sort of approach you could take to doing industrial sheltering to cover those numbers of people. But it also solves a lot of problems right here, right now. You could use it at Burning Man, you could use it for camping, you could use it for sheltering homeless people. I think it might make a pretty good ski lodge. You could do this maybe as a garage, and we tried to encourage vernacular use. We tried to get people actually working with the technology, inhabiting it, using it, living in it. I want to show you a little bit of video, not from me, but from one of the people building Hexiers, just to give you a sense of how all of this works. So this is a video made by a friend of mine who developed a new way of making folding Hexiers. This came out of a project called Space Yard, or LA Launchpad, where we actually deployed a set of Hexiers for homeless people in the LA area on a very quiet basis. And this is very typical of the kind of genre of how to make your own Hexier videos. Somebody who has a breakthrough or an innovation or just wants to show what they've done will basically grab a camera, grab their materials, and they'll shoot a little video to show how to build a Hexier. And these things can be pretty basic. This one is pretty straightforward. Or they can be very, very elaborate, and they've become the predominant way that the Hexier kind of spreads culturally. People make the films, they show them to their friends. They've got a few hundred people that will watch them. Now switching to the second video. And as you can see here, these things are just, the camera's on a tripod, you have somebody just folding up this unit, and it's just a really simple, straight up, direct kind of show and tell approach. What we discovered was that if we made videos which showed every single step in the process without any cuts, just the whole thing end to end for about 3 hours, that was what it took to get the sort of first 6 units built by people that weren't me, physically present building the things. What we discovered over time was that the more people built Hexier, the more sort of simple and direct the instructions could be, because people started with the faith that it was possible and they could do it, and then they just looked at the video for details of how it was going to get done. So this entire sort of approach, this entire sort of genre, has become the kind of cultural footprint of the asset. And that was really the heavy engineering, kind of culturally, psychologically, sociologically, was I didn't want the Hexier to be something that stopped growing if I, for example, died or lost interest or took a job that didn't allow me to do this kind of part-time because I was, say, working for the UN and they wanted, they wanted to control what was happening. So what this gets us is a slightly different way of thinking about how these sort of technologies spread, how this kind of distributed manufacturing works. Because a lot of times distributed manufacturing has a very technical, very digital, very high-tech feel. You sort of have this impression of everything is going to be stored in Git repositories and you're going to download a bunch of DXF files and you're going to cut the pieces in a particular way. And, what comes out of that is a slightly clinical, slightly technical feel, which is very divorced from older models of craft construction. And in my case, craft production. And in my case, craft construction. My grandfather on my mother's side was a Finnish carpenter and a framing carpenter. And so this notion that you would basically take a pile of lumber and you'd kind of take a look at a set of plans, figure out, well, it ought to be about like this, right? He doesn't mean that can't be the way that, we'll just do it the way we always do it. And so you'd always get this notion that the plans were sort of a notional idea of what would happen. And then the guys that were actually framing out the building would do what needed to be done, given the materials they had, given the plans, given what looked right for, drawings might be inexact. And so what I wanted was a building that would be, what I wanted was for the understanding of the building to be fully absorbed and fully captured by the vernacular so that people just viewed it as another kind of simple construction. You could have a tent, you could have a monkey hut, you could have a geodesic dome, you could have a Hexier. A lot of people build Hexiers because they're easy, they're cheap, they're extremely well insulated, and it's quite hard to make an easy, cheap building which is also well insulated. Waterproof is hard enough, but waterproofing and thermally efficient, that's a real challenge. And then what's grown up around this is a sort of subculture of Hexier experts. You'll have somebody doing a camp at Burning Man and they'll be like, okay, here's Bob. Bob is our Hexier guy and he organizes building days and everybody gets together and you have like a barn raising. And at the end of it, you've got 24 Hexiers packed into a sea container. And there are guides for doing that. There are guides for how do you get Hexiers into sea containers, how do you get all the furniture to fit, how is everything placed. But this is a nuanced point. The thing that I was attempting to avoid was the idea that this was a tech project, right? It's a very simple shelter, but it doesn't feel technical to build. In the same way, there's an air conditioning unit, which has become standard. I kind of mocked up a rough version of it out of a little solar powered fan and a bunch of kind of like the square rags that you would see in like an auto parts store. And so the rags were hung as baffles using little bent pieces of paper clips to hold them in place. And it formed a very long snaking air path. So the fan was pulling the air through this air path in this box. And then you'd fill the box, say 4 inches deep with water. All the fabric would soak because it would just absorb kind of up through the cloth. And then the water would gradually evaporate as the air was pulled all the way through the air cloth over this large surface area. Very, very simple. The modern units are much, much, much better. Typically, they're built inside of 5-gallon plastic buckets. And so what we have now is a very substantial community where there are probably 500 people, could be 1,000, who are perfectly comfortable producing shelters and air conditioners as long as they've got a supply of boards and motors and fans and solar panels, and that notion that there isn't really, there's no guild, there's no training, there's no official standard. What we have is just a lot of people have done it for a lot of years. Now it's become an established skill. This is the way that things become vernacular architecture. And that creation of a new vernacular architecture that people have complete ownership of and complete understanding of, that was our goal, because this is a kind of knowledge which doesn't come back out of culture very easily. Those people will remember how to do that in 50 years. They'll be able to teach it pretty easily. And so over time, you just get the establishment of a new way of doing things. Human beings confronted with a situation where they need shelter and they have access to sheet materials like plywood or OSB or Celotex, Isotherm, any of these kind of boards, Armax, they could take that material and they could just turn it into housing. Now, that as an approach, right, this is very culturally distinct from the way that Fab Labs have traditionally operated. The Fab Labs, and I've been involved in a couple of Fab Lab projects and maybe a bit of makerspace stuff as well. The Fab Labs have always carried with them a sort of agenda of like, this is a demonstrator, this is a thing which exists sort of to educate and to show people how the world could work, but they've tended to de-emphasize the use of these things for production. And some of that is, well, if you're going to build an electronic gadget, maybe you ought to go and do industrial mass production of that thing and do it as a business, get yourself a Kickstarter, do this properly. But I think it's also something about the soul of technology. And, I use that term advisedly, right? I don't necessarily mean this literally in the sense of technology has a soul, but the soul of technology in the sense of, the soul of the human being that's relating to a techno-social system. If you take something like Linux, Linux is extremely technical, but it's also completely vernacular because so many people with such deep expertise are using it, modifying it, tinkering it, recoding its, device drivers, whatever it happens to be. That there is now a very large community of people for whom re-engineering the way that your Linux environment works, it's a trivial operation. It's just a thing you do. You need to write a bunch more kernel modules to drive some new piece of hardware, find there are lots of people that can do it, and it's become something that is completely internalized and owned, right? For the people in that community, it is no harder to recompile a kernel with some additional modules built into it than it is for somebody who is in an art school to do like t-shirt printing. And I feel like what we've seen in the Fab Lab world is we've never quite gotten this vernacular style. And I think a lot of that is because there just hasn't been quite the angle in terms of the way the culture works. And here I'm going to go out on a limb because it's a few years since Fab Labs were a fundamental part of what I was looking at. But the impression that I always got was that the Fab Labs were very much like think tanks. They were places where things were done outside of the real world in a special environment that kind of lowered the cost and the difficulty of doing things. And that as an approach, it's very useful for getting a look forward at how things could be, but we are rapidly catching up with the world that the Fab Labs were originally architected in. There is a Facebook group called F That, I'll Just Print It, only they spell out the F. And those folks have totally changed my relationship with 3D printing. Because I always said, look, I've never seen anything made on a 3D printer that I actually desired. I've never seen anything that I wanted. I've never seen anything I would pay for. But that group, right, that group is made of people who don't want to print things, they need to print things. They break a knob off their cabinet, they print a new knob. They're doing some piece of DIY and they, screw up a piece of skirting board, they print a patch that fits into that niche and, they just slot it in and then plaster over it and paint over it and it's done, sorted. They lose some piece of plastic frippery inside of their car and they just print another one, in roughly the right color, whack it into place, off you go. And that as an approach, right, that's a really, really novel, strange, different way of relating to the 3D printer environment, right? I mean, they've still got the skills of 3D printing, they're building their models and they're very familiar with, shape reverse, and they're building their own printers and all the rest of this kind of stuff. But it's gone from like, wow, look at my cool high-tech gadget, to a culture which is almost indistinguishable from woodworking. And that question of whether the high-tech manufacturing environment kind of raises up as part of a kind of pathway towards molecular manufacturing, or whether it slides down the path until eventually you're going to get a 3D printer made from somebody like Makita or Ryobi, and it's going to come with some funny little scanner thing that you wave over a piece that you want to make a duplicate of, and then you hit print, and it's kind of like a job site photocopier. That to me is what I mean when I say that it's something about the soul of our relationship with the technology. Is this a thing for builders and craftsmen, or is this a thing for scientists, technicians, and engineers? And of course, many scientists, technicians, and engineers wear the other hat as well. I'm thinking here of Clifford Stoll, who does a fantastic thing where he blows glass to make Klein bottles out of, at the same time as being, like a sort of leading light in computer security back in the day. So that balance point about our relationship with the tools and our relationship with the culture around the tools, that's the kind of first thing that I want to leave you with. Like, that there is a fundamental question about how a person relates to a tool, right? Am I a scientist? Am I a technician? Am I an engineer? Is this a high culture thing? Or am I a builder? Am I a workman? Am I a craftsman? And to some degree, this is seen as being a low culture thing. And the difference is really only inside of a person. And it's sort of like, how do you feel when you make a mistake? When you bodge it, is it all right? Is it close enough? Or is it like, oh, I was meant to do this right and I've screwed it up? Is anybody watching you when you make something? Is it school class where you're expected to be functioning at this kind of artisanal level? Or is it something you're doing kind of in your own time, and if you're happy with the result, that's it. It's not like anybody's grading you. So that human relational question, the relationship between us and our tools, right? This then becomes a kind of foundation for us beginning to think about our relation with the tools that we don't own, that we don't control, and this is where we get into the questions about industrial mass production and the fate of the world. So the second question is this question of our relationship with industrial mass production. Industrial mass production is killing us. Right? It's killing us and it's killing the world. CO2 is, the front end of the problems with industrial mass production. But there is no end to the problems, right? Toxic chemicals being leached out into the environment, right, left, and center, horrific working conditions. I could go on and list it, and these arguments as well as I do, probably. So, in this step between craft production and industrial mass production, we go from the certain notion of a medieval standard of living, where you have, a blacksmith and an anvil, and that's where all your tools come from, and there is some kind of iron mine somewhere else, and maybe you've got a bunch of woodsmen making charcoal, and the whole village together can just about manage to maintain metal tools as part of an economy with very limited international trade, to the point where, if you order an iPad off Amazon and you live in the middle of a big city, they'll have it to you within an hour. Right? These seem like two completely different universes. The problem is that we're running this universe where you can get an iPad within an hour. We're running that universe on exactly the same energy and natural resource budget that we had back in the days of blacksmithing. The only difference is that there are now 10 times as many people sharing that resource budget, and by the way, half the trees are gone. And this notion of increasing numbers of people and diminishing natural resources with massively increasing material sophistication, refinement, and esotericism, in a world where people are manufacturing diamonds, by creating incredibly hot, tiny little ovens with gigantic amounts of pressure to form carbon into diamond, at the same time as you have sort of, I don't know, maybe 3 million people will starve to death this year. Could be more, could be less. But it's on that order. We still have 1 billion people hungry. We've got vaccine production, distribution issues. I mean, it's, we're in a position where it's very hard to look at manufacturing and say, okay, this is actually serving humanity's needs, or even serving the needs of individuals. I mean, nobody wants to get, poisoned by estrogenic chemicals that are, messing with their, hormone levels as a result of drinking out of the wrong plastic bottle. We're just doing this wrong. And I think part of why we're doing this wrong is because we've lost control of our relationship with the manufacturing process. So this notion that you have this kind of, esoteric level of production where everything is done in a laboratory and it's done by, people in white coats and everything is great, versus kind of down here where you have this kind of like, bunch of folks turn up on a building site and chuck the wood over their shoulders and they go out there and screw the damn thing together and then spray it with concrete. Those kinds of distinctions in how we feel about processes, do we own it? Do we control it? Do we understand it? Or is it done by them far away who are in some way better than us and we trust their judgment over us? And I think this is a thing that, the Fab Lab conceptually has the potential to break down, because by the time you're making your own electronics, no matter how simple, you're beginning to get a real sense of insight into what it is to have a laptop, have an iPad, have a phone, have a camera. You're beginning to understand that these things are simply much more complex versions of the artifacts that you're already making. And demystifying manufacturing to understand that it is a bunch of humans, standing in a long line in the middle of an enormously complex supply chain, clipping these things together one at a time. That gives you a real sense of like, oh, wait a minute, I made this little thing with an Arduino and it's pretty good and it does this and it does that and it does the next thing. But actually, that Arduino, it's made a component soldered onto a board, and then there's the chip in the middle of it, and the chip, you've seen what it looks like to have UV, what do they call them? The mats that they're basically using to make chips, the wiring diagrams. You've seen that stuff. You have an understanding of like, it's just a wiring diagram. It's just a really complicated wiring diagram, but at the end of the day, this thing is made of transistors. And so we begin to demystify manufacturing. If we could get the demystification of manufacturing down to the point where we start asking really awkward questions about, hey, this etchant that we're using, is that okay? As I'm soldering this thing, I am occasionally getting a lungful of flux. Is that okay? That sort of thing. It's very transformative to begin to understand that, like, you get covered in very, very fine wood dust because something goes wrong with your filtering gear when you're cutting a plank. And, rather than the dust being sucked into the, dust vacuum, you wind up, accidentally getting a nose full of the stuff. And then you sort of think like, wait a minute, furniture factories in the developing world, these people have no protection. They're getting lung cancer because they're breathing in hardwood dust. Oh, wait a minute. So seeing ourselves in the role not of, esoteric technicians, but in the role of manufacturers who have some kind of solidarity with all the other manufacturers, I think that is sort of the deep lesson that I'd like us to be able to take out of distributed manufacturing. Distributed manufacturing may not be the most commercially efficient way of doing almost anything, but it is certainly the most humanizing way, because if you are a manufacturer, you begin to think about things like health and safety in a completely different way than if you're not a manufacturer. You begin to feel some common cause and common humanity with the people who manufacture because they have to, not because they want to. And this is a little bit like the thing that happens when people begin to grow some of their own food and they begin to realize that agriculture is not particularly fun when it's not going well. And then you have that little moment of like, oh, farming's hard. Once in a while you'll meet somebody who's like, I keep chickens. And it's kind of like, how's it going? And then, 1 in 3, they'll be like, not so well. And then you hear the chicken horror story, something got in and ate their chickens, or their chickens all died of a weird disease, or they're just being mean to each other all the time. And, you sort of begin to realize like, oh, chickens are kind of difficult to work with. And then there's this moment of like, oh, industrial chicken farms, the matrix for chickens. And, that notion that we run, essentially poultry death camps as a way of life, it's not until you're actually around chickens that you sort of have this realization of like, these things don't really belong in enormous concrete floored warehouses. That is not what a chicken is. That's something that is chicken shaped and is being abused into a different form. Hard to cross these bridges from the position of the only interaction you have with the food supply chain being buying things that are wrapped in plastic, sanitized in a store. Same, and just this experience of like, the first time you cut yourself with a tool, God forbid it's a power tool, God forbid it's a bad cut, but the first time you see, a chisel draw your own blood, and you're kind of, that sort of moment, humans have been cutting their hands making tools for probably 2 million years, 2.5 million years. The archaeologists will find these mounds of flakes of flint and other stone, where the people who were making stone tools just have these discard piles of razor sharp bits of rock. And you can still cut your hand on these things. It's, industrial waste that has a 2 million year lifespan, as Bruce Sterling says in his book, Making Things. So the final thing I want to leave you with in terms of sort of thinking about this is we're going to have to do an unprecedented amount of new industrial design to get through climate change. Almost everything that we do right now just is not fit for a world with climate change as a constraint. Everything consumes way too much energy. I mean, you want to be able to run your house on the same amount of power that the standby electronics take on your current appliances. That's about the power budget for a green world. It's in tens of watts. I haven't done the numbers in a while. And that can be enough energy if everything is designed efficiently, but can't be enough energy if anything is designed wastefully. So, radical constraints on energy, and those constraints are going to be there for a while. Much as cheap solar and wind and all the rest of that are coming along, much as there is discussion of fusion, we can't just wait until we get clean fusion and trust that we're going to be able to pull the carbon back out of the atmosphere in some enormous Hail Mary pass, right? We've seen those promises from the nuclear industry before, and that did not go so well. Similarly, insulation of buildings, insulation of people. I've been experimenting recently with electronically heated jackets. They sell them on Amazon. They're not particularly expensive. They're remarkably effective. That kind of stuff makes a huge difference if you're living in cold climates. And how do you retrofit insulation into existing building stock? You pretty much have two choices. It either goes on the outside of the building and the building looks weird, or it goes on the inside of the building and you've got to worry about all the problems that come from, say, moisture management. And in fact, you have that problem regardless of which side the insulation is on. So there are a whole bunch of problems about, how are we going to retrofit buildings, or are we just going to build a whole bunch of new, extremely efficient buildings and let a huge amount of the existing housing stock that can't be retrofitted go? Where are the experiments going to get done, right? It's going to be individual activists retrofitting a couple of houses and seeing whether they can make it work that is going to decide whether or not those things are practical or impractical. Because, what we really need is something that looks like DARPA level spending to make an enormous investment in figuring out how to do the technological side of climate change mitigation. But right now there is no DARPA for climate change. And if there's no DARPA for climate change, it kind of comes down to us who have the ability to do the experiments, do the research, build the prototypes, take them out, test them, document them, see if they work. It comes down to us to start building out the technology base for surviving climate change. And I guess that's what I had to say today. I mean, I did it, right? I put 20 years of work into getting a technology platform that would be suitable for doing mass construction of housing for refugees. I think it's worked. Not as well as I had hoped, but certainly far better than I expected. And, with another 10 years of work, I think we'll have a fantastic deployable capability. What else is it possible for us to design and build that will genuinely mitigate the oncoming trouble? Thank you very much for listening to me today.